These are alphas. If we are using an alpha 0.05, that means we have up to a 5% chance of making a type 1 error if we reject HO. Whereas if we use alpha 0.01, then we have up to a 1% chance of making a type 1 error if we reject HO. Now, I keep stressing if we reject HO. If we retain HO, then there is no chance of making a type 1 error, right? You can only make a type 1 error if you first and foremost reject HO. These are also level of significance. That's what we call them, the level of significance, because it basically provides the rule that we will follow for rejecting HO, right? You're only going to reject HO if there's less than 5% chance of making a type 1 error, versus you're only going to reject HO if there's less than a 1% chance of making a type 1 error. Okay. So what else do we know about these? Well, let's look at this graph. And using this graph, we are going to figure out which alpha, 0.05 or 0.01, would it be easiest to reject HO. So here we have HO. And HO, because it goes from negative infinity to positive infinity, 0 is going to be right smack dab in the middle here. So we already know that as we increase values of the test statistics, so remember that these are TS values plotted underneath HO. So these are negative TS values and these are positive TS values. So as we increase, right, these TS values, as they get larger and larger, well, what's happening to their probability under HO? Their probability is becoming smaller and smaller. So the TS with the highest probability under HO is 0. And then as the numbers increase in this direction, the probability of those TSs are going down. Same thing here. As we increase the values of the TS in the negative direction, their probabilities are also going down. Now, because HO is symmetrical, whatever is happening in this tail is going to be mirrored in this tail. So whatever is true for this tail is true for that tail. I am going to choose to focus on this tail. And the only reason for doing that is just because we seem to be more comfortable using positive numbers than negative numbers. All right, but in reality, it really doesn't matter which tail we look at because the rules are the same, regardless if it's positive or negative. Okay, so let's say we want to use alpha 0.05. Well, if we're using alpha 0.05, that means we're going to have 95% in the middle of the distribution. And this 95%, if our TS were to fall anywhere in that 95%, we would not reject HO. We would retain HO. All right, if we have 95% in the middle, what size are the rejection zones? Well, combined, they have to be 5%, right? Because 95 plus 5 gives you your 100%. So if we have 5% as our rejection zone, we have to divide that up between the two tails. So we're going to have 2.5% in this tail and then 2.5% in this tail. And I just realized that I haven't drawn them symmetrically because look at the size of this 2.5% versus this one. Oops, well, this is approximate, okay? So just pretend there's 2.5% here and 2.5% here, all right? 95 in the middle. Now, whatever this TS value is, and I don't know what it is, but whatever it is, this becomes our critical value. So this is the TS or critical value for the alpha of 0.05. Okay. Anything greater than that critical value, we're going to be able to reject HO. Okay, now what if we wanted to use alpha 0.01? Well, if you're using alpha 0.01, that means that this middle area is 99%. So if our TS falls anywhere in that middle 99%, we would retain HO. If, however, we want to reject HO, we have to know, well, how big are the two rejection zones? Combined, those two rejection zones are going to be 1%, right? Because 99% plus 1% gives us our 100%. So if it's 99%, we have to split that up equally between the two tails. So that means we're going to have a 0.5% in this tail and a 0.5% in this tail. All right, so whatever our critical value is, because this TS, right, is going to be the critical value for alpha 0.01. So I don't know what this TS is, but it's basically that number tells us where the rejection zone starts. So again, this would be the TS value, and it's special because we're going to call it the critical value for alpha 0.01, such that there's a 0.5% of the area under the curve is here. Okay, same thing on this side, right? So whatever this critical value is, that's the TS that starts the rejection zone on this side, such that there's 0.5% area here under HO. Okay, this area here is a 0.5%. Okay, now let's compare these two critical values. Well, if you're a test statistic, remember you have to be larger than the critical value to fall into a rejection zone. Which critical value, the one for 0.05 or the one for 0.01, which one is going to be a smaller number? Well, it's going to be this one, right? Why? Because we've already said that the TS values are increasing as we move into the tails. So whatever this number is here, let's say it's 4, this one has to be larger than 4. So again, if you're a TS, the one that you actually calculate, right? You're the one that SPSS gives you at the end, like to say this is the test statistic for the test we just calculated. That test statistic, if it's bigger than 4, let's say, so this is 4. If it's bigger than 4, then we can say it's significant. It'll fall into this area. But what if this critical value is 5? And your test statistic, the one you calculated, is 4.5. Well, it's not going to be big enough to get over this critical value. All right, so again, if this CV is 4, this CV is 5, and your specific test statistic that you calculated is 4.5, you're going to fall into this rejection zone for an alpha of 0.05, but you won't make it into this rejection zone if you use alpha 0.01. So you see how by using alpha 0.05, you actually make it easier to reject HO? Now, in reality, let's say that you set your level of significance to be 0.01. And let's just pretend you got a test statistic right here in the middle. So in other words, it would have been significant at 0.05, but it's not significant at alpha 0.01. Guess what you're going to do with your original statement. So your original statement was, I'm going to use alpha 0.01 as my level of significance. Well, here's what you do. There's a special key on your keyboard, and it's called delete. You hit that, delete, 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 and you change your level of significance to 0.05. Nobody's going to know, right? We do this all the time. Just change it to alpha 0.05, and now you can say that you have a significant result. It's not cheating. You can decide afterwards that you want to be a little more liberal than you first thought. You were hoping to be able to reach significance at 0.01. It didn't happen. No biggie. Just adopt the 0.05 alpha for your level of significance.